Hi, everybody. Welcome to the podcast. And this is Susan Clinton, one of your co-hosts. This is one of our short podcasts this week, and this is going to be part one of a webinar on the interactions of the functional anatomy and physiology of the GI system. One of the things to pay good attention to here is unique anatomical arrangements around the GI system and its neurophysiological connections. Enjoy the podcast. I look forward to your feedback. Thank you. The first part of the course, we're going to cover a little bit of the anatomy and physiology of the GI system as it relates and pertains to physical therapy. What I want you to remember, when you look at the abdomen and the abdominal region, we are looking at all of the viscera in the visceral cavity. So we have a very large liver on the right side, the stomach that is underneath the liver at the epigastric region on the left side. We have the ascending, the transverse, the descending colon. We have the sigmoid colon down into the pelvic cavity and the rectum in the pelvic cavity as it turns into the anal canal. There's the small intestine lies in between and on top of colon all the way around it. The colon sits a lot lower in the body than you think it does. It really is sitting down low, closer to the lower lumbars. It's not up high. Most people think it's up very high up into the thorax, and it's really not. It sits really down low as in the lower part of the abdominal cavity. I think it's important to understand where the visceral organs are located within the abdominal cavity. So we have the visceral cavity, which is surrounded by the peritoneal wall. And within the peritoneal wall, we have the liver, we have the stomach, the transverse colon, the small intestines, all housed inside, including the greater omentum, which is the apron off of the base of the stomach. All of these things are located within the visceral cavity. Outside of the visceral cavity, or retroperitoneal, are the kidneys, the ureters, and the ascending and descending colon. The descending colon turns into the sigmoid colon as it enters the endopelvic fascia and becomes the rectum, and then finally the anal canal. Other visceral organs such as the uterus, the prostate, the bladder are all located in the pelvic cavity below the parietal wall. Why is this important? Why am I bringing this up? We have pressure differentials between the abdominal cavity and outside of the abdominal cavity. And so if the ascending colon and descending colon are outside of the abdominal cavity, then there are pressure differentials that they have to overcome to go back into the abdominal cavity. In other words, as we move up the ascending colon and into the flexure, that's the entrance of the ascending colon to turn into the transverse colon as it goes into the peritoneal cavity. Same thing occurs at the splenic flexure when the descending colon comes down and out. Those pressure differentials are designed to help move stool and liquid and content through the colon as we move with our body. So as we lean over and move and twist and turn, our colon is lifted and twisted and pulled across those pressure gradients as we go through life. Also breathing, the diaphragm descending, pushing on the visceral cavity, is going to pull on those flexures and their ligamentous sources, so that's going to help move things through as well. So it's all a matter of why things are there and why they're not there. It's all because we need those differences in pressure and differences in chemistry that both of those regions provide. Let's talk a little bit about the neurology of this entire region because it's very, very, very important. So we have a central nervous system, which is going to be our cerebral cortex and our limbic system. That's who you are. That's your eye brain. That makes sense. That's your personality. That's your likes, your dislikes. It's all the things that make you uniquely you, and your emotional and sympathetic reaction to everything. Also attached to the central nervous system is the brainstem and the hypothalamus. And the brainstem is going to be the operator of all of our visceral functions and all of our autonomic functions that keep us going. It's important that we are able to walk without having to think about our foot lifting off the ground and where we're putting it down every step, because we would not be able to pay attention to our environment. A lot of the things need to work in the background. Your heart rate can go up and down. You certainly can affect it going up and down through your eye brain or your cerebral cortex, but it's going to really actually be running automatically most of the time because we're not going to be concerned about it. We're going to be concerned about doing the things that we do that we want to do. The hypothalamus is going to be involved and intimately involved with running the hormone changes in your body in response to the stress system. So it's very important that it has a strong connection into the brainstem and into all of the cranial nerves and into all of the other pathways that are going to cause us to be awake, cause us to be asleep, and actually help us with all of the other functions in the background. Both of the central nervous systems that we just talked about, the cerebral cortex, limbic system, and the brainstem and hypothalamus, have very strong connections to our second brain, which is the enteric nervous system. And the enteric nervous system is the one that runs the entire show for the GI system. It's very important. It's got all kinds of neurons, and they're very specific to the GI system. And there's a lot that goes on there. The two connections between these two systems are the vagal pathway and the splanchnic pathway. Obviously, the vagal pathway is the parasympathetic pathway, and the splanchnic pathway is the sympathetic pathway. I want you to keep in mind with these arrows that they're very important, that these systems are binary. They move up and down. It's not just a one-way top-down or a bottom-up type thing that goes on. There's a flow, there's an ebb and flow between the sympathetic and the parasympathetic. One tells the other to quiet down some, one tells the other to pick up some. One says, I need you to quiet down more, will we pick up more? There's all kinds of conversation that goes on, and much of that conversation is governed by the enteric nervous system. Within the enteric nervous system, this is where we manufacture serotonin. That's a neurotransmitter that the central nervous system needs to control its limbic function and to also be able to make good decisions and plan and do the things that it needs to do. If we have an illness in and around our GI system, we're not able to really manufacture that neurotransmitter as efficiently or as effectively, and that can lead to big changes in the brain. Thinking about the enteric nervous system on the other end, there's all kinds of processes that are happening here. And that's going to be your enteric afferents and interneurons. You're going to have neurotransmitters, neuropeptides, other chemical and mechanical stimuli that's going to be affecting the enteric nervous system. And the enteric nervous system is going to govern the secretion, mobility, and blood flow of a lot of the things that are going on in the gut and what's actually happening there with our digestion and making sure things get to where they're supposed to get to. So we have both of these systems working, they're working together, and they do communicate together. If one is offline, it can really make the other one not well either. This picture is just demonstrating the nervous pathways that come out of the brain and out of the spinal cord to the various organs of digestion. And you can see that on this picture, we've got the head and the mouth up there, which are part of digestion. We've got the airway that's going on. You've got the esophagus to the stomach, the liver. You've got all of the small intestines in there, the colon, and all the way down to the rectum and the anal canal. And those connections, definitely talk to each other through the vagal and splanchnic system, but they also have their own connections, back into the spine and through the ventral medulla, where they connect and hook up and can talk to each other there as well. This picture brings up not only the parasympathetic and the sympathetic system, but it brings it up a little bit higher and brings in things like the eyes and the salivary glands, which are also very important. We see our food, we start to drool, and it's time to eat. It's all part of the same system. There's a reason that there's $1 billion industry around how food looks on billboards. They're counting on that very strong connection in your parasympathetic system to stimulate your salivary glands and get the chemicals changing in your body to say it's time to eat. We're ready to eat. We want to eat that. We want to eat that now. And they're counting on that you'll pull off of the highway and go find that place and go eat what they have on that billboard. So keep this in mind. This just shows all of this. I think the only thing that's flawed in some of the slides that are out right now is because they haven't kept up yet with the new neurology that's coming out. And one of the things that we know now in some of the neurophysiology books is that in studies that they're doing in France, they're actually finding nucleotide markers in what they thought were parasympathetic nerves to the bladder coming through the pelvic nerve there. They're finding that to be much more sympathetic and not as parasympathetic. So these pictures will change as we go. That makes for a lot of issues, though, when you think about when people get nervous and upset, or they're getting ready to perform, or a big thing is happening in their life, and their hands are cold and sweaty, and their breathing is a little bit more shallow, and then they have to go to the bathroom. It's like, why do we have to go to the bathroom? It shouldn't be that, because I have always heard that sympathetic means store, like, no, we're not going to the bathroom now, we have to do this. And it's the opposite. It's kind of like dump and run. We need to get rid of this stuff so we can be at our peak performance. I put this slide up here not because I'm going to talk about each one of these muscarinic receptors. I just wanted to remind everybody how many there are in the body and how many are coded in our digestive system. So we have muscarinic receptors in our salivary glands, our parietal cells, the smooth muscle of the GI system, the sphincters of those smooth muscles, and the glands that secrete into our GI system. These are important because oftentimes the medication that patients are given for urgency frequency for their bladder actually affects the muscarinic receptors of the GI system. So that's why their mouth gets dry. And that's why they get more constipated. The interesting thing is that constipation is a huge driver for urgency frequency of the urinary system. So you're taking the system, you're medicating it to try to get them to not have urgency frequency, but yet you're overloading the driver of constipation behind it, because now the GI system is being slowed down by these drugs. It's important to know and see the connections of the mesenteric system as well. And the mesenteric system is where the enteric nervous system attaches to the spine and where the nerves can flow out and back to. And I think it's important because the enteric nervous system actually communicates back through that region to get up to the vagal system. So the vagus comes down around the heart and into the stomach and then back into the spine. And there's a lot of crossover with the enteric nervous system and the vagal system right at that region. So it gives us two brains in one body, with one governing the gut, which we're finding out governs more than just the gut. It actually has large influences on the behavior of the brain. In this particular picture, we're going to just go through this so that you can kind of get an idea of what's happening here. On the right is the colon. On the left is the nerves. So we've got sensory nerves, we've got the parasympathetic nerves, which are motor. And then we've got the sympathetic motor nerves all in their spots here. And now what's happening is that they're moving and crossing into the longitudinal muscle and having their effect there where they will dilate and contract and cause that muscle to do all of the different things that it needs to do. So the parasympathetic system, motor-wise, will get peristalsis going. The sympathetic system will kind of stop peristalsis and kind of halt that activity because we don't need it when we're running from the saber-toothed tiger. As we cross through the longitudinal and the circular muscle, we get into the submucosal plexus. And so the submucosal plexus are all the nerves that are actually working with and helping the blood vessels. So this is going to be your restriction and dilation of your circulatory system right into the colon wall. Very important that you see this because it's the enteric system that really does this as we move forward. Into the mucosal layer, which is on the other side of the mucosal, of the wall of the intestine, is the mucosa, and it's a lining that covers that intestinal wall. And you'll see in that lining we have endocrine cells, mechanoreceptors, chemoreceptors, and secretory cells. So the mechanoreceptors are important there. Why? Because if we have bacteria that is eating and fermenting gas, that can affect the mechanoreceptors. Pressure in the lumen may track back through the sympathetic or parasympathetic enteric nervous system, hook up with the vagus, say, we got a lot of gas down here, and the vagus may hook up with the sympathetic system and say, dude, you need to breathe a little bit easier and stop eating so fast. We're getting gas down there. So it can have this kind of effect. The chemical receptors are important because there's certain chemistry that needs to occur. As we have foods that are more acidic, it could change the pH of our GI system, and that can affect the health and the wealth and the numbers of our gut microbiome. When we have a problem or an issue with the wrong kinds of secretions coming on, so if you look over to the left and see the sympathetic, and then you'll track it over, you'll see that it goes to a lot of secretory cells there. When we start secreting all kinds of things like adrenaline and the breakdown of adrenaline and the breakdown of cortisol and things like that that are going into this mucosal layer, over time that damages the cells of the mucosal wall. When we get damage to that cell wall, the things that should be being broken down and chomped on by the gut microbiome actually slip through the cell wall and fall into the submucosal plexus. When it's there, it's actually entering the blood supply. When we have things that shouldn't be in the blood supply entering the blood supply, we will have an immune reaction. That means our inflammatory markers will go up. We will start having mast cells producing the things that they produce, the antibodies, and then we'll have histamine responses and things like that, because we simply have things that are getting into the circulation that shouldn't be getting in there. And it's because the cell wall has broken down in the gut mucosal layer. This is why stress over time can be really, really, really damaging to the GI system. Same thing occurs if we're really sick and we have to take some high-powered antibiotics. That changes the number of microbiota that we have, and we have different ones that grow in response to that, and they could also be responsible for damaging and making the cell wall more fragile. Again, more things will leak out, we have more histamine reactions, and the immune response, that occurs with it. This slide is going to talk to you just a little bit more about the chemistry, because there's multiple transmitters of neurons that control digestive function. So this is just a way to kind of just say the enteric nervous system is extremely complicated, and we're not real sure what all it does, but we do know that it has more power than we ever thought. Tracking out and looking at a little bit more macro anatomy rather than micro anatomy that we were looking at 2 slides ago, we're going to be doing the same thing here. So I want you to just get oriented to the slide. You'll see the lumen of the intestine, and the next thing next to the lumen is the mucosal wall, right? That's the wall that can get the cell damage, and when the cell damage occurs there, that's when we go up. If you go to the submucosal lining, you'll see the nerves there. And remember, blood vessels always follow nerves. They all track and go together. So that just kind of shows you the longitudinal and the circular muscles and the different layers of the intestine all the way down to the lumen.